Welcome to today's tutorial by Caz Academy. Today I will be giving you an in-depth tutorial of the Accuplacer Next Generation Arithmetic Exam. Today I will be going over the official study guide and giving you tips and techniques for answering the arithmetic questions. Be sure and see the links in the description below for the official Accuplacer study guide materials, as well as additional supports and resources to help you pass your arithmetic exam. On your exam, you will be tested on whole number operations, fractions, decimals, percents, number comparisons, and equivalents. I have additional videos on all of these topics, and you can find links to those videos in the description. On your exam, you're going to be expected to understand the relationship between decimals, fractions, and percentages. So let's look at problem number 14, which gives us a decimal, a percent, and a fraction, and asks us which of the following correctly orders the values above from least to greatest. So whenever they give you numbers in different formats, you need to put them in the same format. And usually the easiest way to compare them is to convert everything to a decimal. So let's write down each of our numbers and then convert them to decimals. So the first number they give us is 0.075. This is already a decimal, so I can just write that down and I don't need to do anything else with it. This next one is a percentage, 0.75%. Now notice that the decimal is to the left of the 75. So I'm going to start at the decimal, move 2 places. That's going to tell me where to put my decimal. So that's going to give me 0.0075. Now note that this is a very different problem than if they had just given me 75%, which has an imaginary decimal to the right of that 5. And if I move that to decimals, that's going to give me 0.75. They're going to trip up a lot of people. A lot of people are going to get this problem wrong because they're not going to pay attention to that decimal. That's going to give you a different answer. If I have a fraction and I want to convert that to a decimal, then I'm going to tip the fraction on the side. I need to do long division. The bottom number goes on the outside, top number goes in the box. You want to make sure you get this order correct. If you flip that division, then your answer is going to be wrong. So let's go ahead and do the long division. 4 can go into 3 0 times. So I'm going to add a decimal and some zeros, bring down my 0. 4 can go into 37 times, which is 28. Remainder 2, bring down another 0. 4 can go into 25 times. So that gives me 0.75 as my decimal conversion for my fraction. So now that I have my decimals, I'm going to write each of those down so I can easily see them and I can compare them. So when you are comparing to identify the smallest numbers, you're going to start with the first digit after the decimal to compare which one is the smallest. So we've got 2 that have a 0 after the decimal, so that means I'm going to go to the second digit to determine my order. So this one has 2 zeros after the decimal. That means that one is the smallest. And that one matches up with my 0.75%. So when I convert that back, that's going to be my smallest number. Now I'm going to go and look for my second smallest. So once again, I'm looking at the digits after the value of the digits after the decimal. Now I'm comparing the first again. I've got a 0 here and I've got a 7. So that means this is going to be my number 2 and this is going to be number 3. So number 2 is 0.075, number 3 is 0.75. And then I convert each of these back to their original format. So now that I've converted them to decimals, put them in order, and then I've converted them back to their original format. So now I know what it is that I'm looking for in my answers. And I see that answer A matches the numbers that I solved for. So problem number 6 is another problem where we're going to be looking at comparing values. We've got fractions, they've given us fractions and decimals. We need to convert them all to the same format and determine which one of these has the greatest value. Now, because we're not necessarily putting them in order, we're just looking to determine which one is bigger. So because of that, we can take some little shortcuts without having to actually convert them to decimals. So the first thing that we want to look at is what have they given us? So they've given us 2 fractions and 2 decimals. So I'm going to start with these 2 decimals. And I'm going to determine out of these 2 numbers which one is bigger. And I can do that by looking at the number before the decimal. I've got a 2 and a 0. So 2 is bigger than 0, so that automatically tells me answer D is not going to be the biggest number. The next thing I'm going to look at is I'm going to look at my fractions. So on my fractions, they gave me an 8 over 3 and they gave me a 10 over 12. So if you will recall, on our fractions, if I have an improper fraction, so an improper fraction is going to be greater than 1 because the top number is bigger than the bottom number. And just a regular fraction is going to be less than 1 because the top number is smaller than the bottom number. So when I look at each of those fractions, I'm going to determine, are they going to be greater or smaller than 1? My first number, 8 over 3, that's an improper fraction because the top number is bigger than the bottom number. So that tells me that number is going to be greater than 1. The bottom one is a regular fraction because the top number is smaller than the bottom number. So that means that's going to be smaller than 1. So that means my 8 over 3 is going to be bigger than 10 over 12. So another way that I could write this using inequalities is I could say let's write that a little differently. I could say 10 over 12 is less than 1, which is less than 8 over 3. So once again, 10 over 12 is not going to be the biggest number. So now the next thing I need to do is I need to determine out of 2.28 and 8/3 which of these 2 numbers is going to be bigger. So in order to do that, I'm going to take my 8/3 and convert that to a decimal using long division. So you remember with long division, we tip it to the right, bottom number goes on the outside, top goes in the box. 3 can go into 8 2 times. 8 minus 6 is 2. I've got a remainder, so I'm going to drop that 0. 3 can go into 26 times, which is 18. Okay, and then I don't need to do any more math because I'm just comparing the numbers. So they both started out with a 2, so that means I needed to go to the next number. The next one, that's 0.2, and this one is 0.6. So 6 is greater than 2, so that tells me that 8 over 3 is going to be my biggest number. So that's how you would solve. That's the easiest way to solve when you're given a variety of numbers, decimals and fractions, and we want to compare them. You're going to do a process of comparing the inequalities to determine what is greater and what is smaller, as well as converting each of those to the decimal. The other way that you could solve this is you could convert each of these convert your two fractions to long division, make those decimals, and then put them in order from smallest to largest or largest to smallest, similar to what we did in problem 14. In this problem, we're asked which of the following fractions is equal to 0.06. So as you have seen in the problems before, that when we are converting fractions to decimals, we do that by doing long division. So with this one, we're going to see if we can't take some little shortcuts so that we don't have to do the long division for all 4 of those fractions. So the first thing that we want to identify is to look at what are the similarities and what are the differences. So you'll notice with answer A and answer B, we're dividing by 6. We got 1 on the top and a 6 in the denominator. So we would guess that those two answers are probably going to be pretty similar. The same thing with answers C and D. They both have a 6 in the numerator and a 10 in the denominator. So I would guess that my answer is going to be either from either group A and B or from group C and D. So when I'm deciding to do my long division, I'm going to do a long division from the first group, and if that's not the correct answer, then I'm going to do a long division from the second group. That's going to help me to make my choices on the order, and then hopefully I won't have to do the long division on all 4 problems in order to get my answer. So let's start with problem number 1. Answer 1, I have 1 over 6. I need to convert that to a decimal, so I'm going to put 6 on the outside, 1 on the top. 6 can go into 1 0 times, so I'm going to add some zeros. 6 can go into 10 once. So this already doesn't match. I've got a 0.1 and I need a 0.0. So I'm going to go ahead and stop at this point. I don't need to do any more division because I already know that's not going to be the correct answer. And that also is going to tell me that answer B is probably not the correct answer either. So I'm going to move down and do the long division on problem C. So that's 6 over 10. I'm going to do my long division. Bottom number goes on the outside, top goes in the box. 10 can't go into 6, so I'm going to add some zeros. 10 can go into 60 6 times. So right now I've got a 6 after the decimal and that one's a 0, so I know that that one is also not correct. But I do notice that I have a 0 and then a 6, so I've got a 6 in my answer. I've got a 6 in my answer and a 6 on the top. So I'm going to now do problem D to see if I divide by 100, if that's going to move that over to give me that 0 before the 6. So I'm going to put the bottom number on the outside, 6 goes on the top. 100 can't go into 6, so I'm going to add the decimal and some zeros. 100 can't go into 60, so I'm going to put another 0. 100 can go into 600 6 times. And I see that that matches my answer, so that tells me that answer D is going to be the correct answer. So, and because answer D was the correct answer, if I had just gone through and done the long division for all of them, I would have done 4 problems instead of 3. So by grouping them together, noticing the similarities, I did 2 things. One is that I saved myself from having to do an extra problem, but I also paid attention to as I was solving the problem so that I didn't have to do all of the long division. So that's going to save me a little bit of time and having to do a little bit of extra to solve that problem. Problem 11 is another question that's going to test your understanding of the relationship between fractions and decimals. It's also going to test to make sure that you know how to do long division correctly. So, as we've talked about before, when you have a fraction, we use long division to convert it to a decimal. So we're going to tip to the right, the bottom number goes on the outside, top number goes in the box. 25 can go into 8, 0. So we're going to add a decimal and some zeros. 25 can go into 80 3 times. Drop the 0. 25 can go into 50 2 times. That's going to give us our answer of option B. Now, where they're going to catch people is if they do the division incorrectly. So this is the correct. If I set it up incorrectly and put the top number on the outside, the bottom number on the inside, 8 can go into 25 3 times. Going to add my decimals. 8 can go into 10, oops, not twice, once. The remainder of 2. 8 can go into 22 times. 8 can go into 45 times. And if you'll notice, this is answer D. This is the incorrect answer. When you are doing your problems, a lot of times they're going to have on your options is they're going to know what are all the mistakes, the common mistakes. And one of the common mistakes with long division is to set up the long division incorrectly. And that's why that incorrect answer is going to be included as one of your options, because they know that a portion of people are going to set that up incorrectly, and then when they see that answer as one of the options, they're going to think that they've done that correctly. So that's one of the things that you want to make sure when you are converting a fraction to a decimal, or that anytime you're doing your long division, you set that up correctly. The top always goes in the box. The top number, where's my mouse, always goes in the box. The next set of problems that we're going to be looking at are problems using whole number operations. That's your adding, subtracting, multiplying, and dividing. So for most people, these are going to be real easy, and it's a good place to get some added points. The biggest thing that you need to watch out for is to make sure that you're using the correct function. Oftentimes when you have a little bit of anxiety, or you're going too fast, or you're not paying attention to the problem, what it's asking for, that's where people make mistakes and they use the wrong function. So for example, this problem is an addition problem, but if you're not paying attention, you could easily turn that into a multiplication or a division problem, and then you'd end up getting the wrong answer. So I guarantee you that on your options, the writers of the exam are going to take that into account, and you will usually have one of your answer is going to be solving that with the incorrect operation. The other thing you want to keep in mind is making sure that when you are writing these down, that your alignment is correct. So for this example, you'll see that my rows and my columns are clearly labeled so that I can easily identify what is supposed to be added to something else. If I was to write it like this, not really paying attention, or being a little bit sloppy with my alignment, then the columns aren't very clear, and I have potential for making an error in adding that up incorrectly because I'm not lining them up correctly. So let's go ahead and finish this problem. 2 plus 1 is 3, 8 plus 6 is 14, 7 plus 5 plus 1 is 13, 1 plus 1 is 2. 2, 3, 4, 3, and our answer is problem D. Problem number 4 is a story problem, so we need to look for our word clues to help us to know what type of problem we're going to be doing. This one says a conference planner has put together 280 binders for attendees and another 31 binders for presenters. How many total binders did the planner put together for attendees and presenters? So we know we're working with the numbers 280 and 31. We have the word and total. So and usually means sum or addition, and total usually means equals. So that tells us we're going to take 280 plus 31, and we want to know what does that equal. So let's write it up, align it correctly, align it to the right. We're doing addition again. 0 plus 1 is 1, 8 plus 3 is 11, 2 plus 1 is 3, 311, and that is option C. The next one is another story problem. This one says that a club has 36 members. If each member donates 12 items for an auction, how many items will there be in the auction? So this one, we're dealing with the numbers 36 and 12. And we want to know, it says if each member donates 12. So that means for every member, each one of those individuals is going to donate 12 items. So that tells me this is a multiplication problem. Then that will tell us how many items will there be in the auction. So we're going to set this up to multiply. We line up everything to the right. 6 times 2 is 12. 2 times 3 is 6. Plus 1 is 7. I do an X for my placeholder. 1 times 6 is 6. 1 times 3 is 3. Now I'm going to add them up. 2, 7 plus 6 is 13. 3 plus 1 is 4. So 432 is my answer. When you're doing your multiplication and you're adding, it's really important that your rows and your columns are clearly written so that everything's lined up correctly so that you're not making an alignment error. Kai Ming is making cookies. Each batch of cookies uses 3 eggs. If Kai Ming has 20 eggs, and assuming he has enough of the other ingredients to make the cookies, what is the greatest number of batches that he can make? So there's a couple of things that you want to watch out for. We want to know the greatest number of batches that he can make. So this right there tells us we're looking for a whole number answer, which is what they've just given us the options. We have 3 eggs for each batch and a total of 20 eggs. So this tells us that we are looking for a division problem of, we're going to take 20 eggs, that's the 20 eggs total. We're going to divide it by 3 eggs needed for each batch of cookies to find out how many batches he can make. So now we're going to do our long division. 3 can go into 26 times with the remainder of 2. Now, we just want to know the number of batches. So 6 is our final answer because that's the number of batches. So this is going to be total batches. And the 2 is going to be number of eggs left over. So for this problem, it's looking to see, do you know how to do a division problem and setting up your long division correctly? So our answer would be B for 6 eggs. If they wanted to know how many eggs would be left over, your answer would be 2. So number 12 says, what is the remainder when 599 is divided by 9? So once again, we have a division problem. So division problems can be written like that, or you can write it so that's horizontally or written vertically. But the main thing to remember is when you're doing your long division, that it's the second or bottom number that goes on the outside and the first or top number that's going to go inside the box. Now let's go ahead and do our math problem. 9 can go into 59 6 times. That's going to give me another 6. 9 minus 4 gives me a remainder of 5. So this time they're wanting the remainder. So my answer is going to be 5. Problem 16 is a rounding problem. So this one says, what is 0.8637 rounded to the nearest hundredth? So the first thing we need to identify is where are we rounding to? And this one says we're going to round to the nearest hundredth. Nearest hundredths is 2 digits after the decimal. So that's going to be this spot right here. So that tells me my answer is only going to have 2 digits after the decimal. So that automatically is going to get rid of answer B and C as an option. Now I need to do the actual rounding. So when I'm doing rounding, I'm going to decide where I'm going to stop. So in this case, it's the hundredths, which is 2 digits after the decimal. Then I'm going to look at the digit to the right of wherever I want to stop. If that number in the box is greater than or equal to 5, I'm going to add 1. If the number in the box is less than 5, I'm going to add 0. So our number in the box is a 3, and 3 is less than 5, so that means I'm going to add 0. And my final answer is going to be 8.86, and that is answer A. The next set of problems that you need to know how to solve are decimals. You need to know how to add, subtract, and multiply decimals. So when you are adding and subtracting decimals, you need to line up the decimals. So they've given us a problem with 3 decimal numbers, and all we're going to do is we're going to write them so that all of the decimals are in a row. So all right here, the decimals are lined up. Doesn't matter what's in front or behind the decimals. Any number they give you, it's going to align by the decimal. And if I'm missing numbers, I can add zeros as placeholders to the right to help make sure that all of my numbers are lined up correctly. So now that I have all of my numbers in clearly written rows and columns, now I'm just going to do my adding. 4 plus 7 is 11. 5 plus 1 is 7. 8 plus 1 is 9. Going to bring my decimal down, and 3 plus 0 is 3. So my answer is answer C. Problem 13 is another word problem. It says a machine is currently set to a feed rate of 5.921 inches per minute. The machinist changes this setting to 6.088 IPM. By how much did the machinist increase the feed rate? So we're looking at the difference. So we know we're going to use the numbers 5.921 and 6.088 IPMs. And we want to know how much did the machinist increase the feed rate. So we're looking at the difference, and it says the machinist changes the settings. So we're looking for the change. We also know that we are dealing with decimals. So the rules for decimals is that we need to line up the decimal points. So we're looking for the difference. So that tells us it's going to be the subtraction. So we're going to take the higher amount and we're going to subtract that, or we're going to subtract the lower amount from the higher amount. Now you want to remember that with decimals, we want to line up the decimal points. So now let's go ahead and do subtraction. 8 minus 1 is 7. 8 minus 2 is 6. I have a 0, so zeros have no value, so I need to go to the number to the left to borrow. I'm going to change that to 5, bring over a 1, that makes 10. 10 minus 9 is 1. I'm going to drop down my decimal because I want my decimals lined up. 5 minus 5 is 0. So my answer is 0.167 inches per minute, which is answer A. Problem number 15 is the multiplication by decimals. This one says, what is the value of 2.84 times 3.9? So the thing you want to remember with decimals is that when you add and subtract, you line up the decimals. When you multiply, you line them up just like regular multiplication. Then you count the number of digits behind decimals. So let's write down our problem. We've got 2, 8, 4, and 3, 9. So when you're doing the original multiplication, we don't need to worry about the decimals. We just need to make sure that they are aligned to the right, just like we do with regular multiplication. Now we're going to do our regular multiplication. 4 times 9 is 36. 9 times 8 is 72, plus 3 is 75. 9 times 2 is 18, plus 7 is going to be 25. Then I do an X as my placeholder. 3 times 4 is a 12. 3 times 8 is 24, plus 1 is 25. 3 times 2 is 6, plus 2 is 8. Now I'm going to add 6, 7, 10. 8 plus 2 is 10, plus 1, which is 11. So now I've got 11076. So now the next step is to figure out where my decimals go. And then with the decimals, you count the number of digits behind the decimal point. So I've got 2 from my first problem, 1 from my second number. That gives me a total of 3 digits behind the decimal. So that means I'm going to start here at the right and go in 3 places. And that tells me where my decimal goes. So that tells me my answer is going to be B at 11.076. Our next set of problems are percentage problems, and I do have extra videos on decimals, percentages, and fractions, so be sure to see the links in the description to get those tutorials if you want more practice. So let's look at this problem. Problem number 7 says if Manuel deposits 25% of 130 into a savings account, what is the amount of his deposit? So if you recall from the percentage tutorial that we can put all of our problems into the formula of A equals B% times C, where A is a portion, B is the percent, and C is the total amount. So let's look at what they've given us. The first thing we can identify is we've got 25%, so that is our percentage of means multiply. 130 is going to be the total amount. So that's my C, and we want to know how much was his deposit. So now we're going to solve this problem. Whenever you have a percentage, you need to convert that either to a fraction or a decimal. So we can convert it to a decimal by moving the decimal place 2 digits to the left, or we can create a fraction by dividing by 100. So for this problem, whenever I'm solving for the portion, I like to use percentages, but you can solve it using fractions as well. So the two options that you could do, you could either say A equals 0.25 times 130 and multiply by decimals, or you could say the portion is going to equal 25 divided by 100 times 130. Now if you remember that 25% equals 0.25 as a decimal equals 25 over 100. These are all equivalent statements, and it's important that you know how to convert back and forth between percentages, decimals, and fractions. So let's go ahead and do this multiplication by decimals. If I take 130, multiply that by 25, 5 times 0 is 0, 5 times 3 is 15, 5 times 1 is 5, plus 1 is 6. Do an X as a placeholder. 2 times 0 is 0, 2 times 3 is 6, 2 times 1 is 2. Now I'm going to add that up. 0, 5, 12, 3. Now I'm going to look to my original problem, or my percentages. So this is my equation. A equals 0.25 times 130. I've got 2 digits behind the decimal, so that tells me I'm going to move my decimal place 2 digits to the left. That's going to give me a final answer of 32.50. So C is going to be my final answer. Problem number 5 is also a percentage problem. So let's work this problem through. It says a store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 of the cans sold. What percent of the cans of popcorn stocked were sold that weekend? So we know that when we're solving percentages, we want to get them in the formula of A equals B percent times C, where A is a portion, B is the percent, and C is the total amount. So let's look at where these variables go. It says the store stocked 150 cans of popcorn for a weekend sale. So that's the total number of popcorn stocked. So C is going to be 150. Then it says that weekend 72 of the cans sold. So out of 150 cans that we started out with, we have 72 that were sold. So 72 is going to be a portion of the total. So that is our A. Then it asks us what percent of the cans of popcorn stock were sold that weekend. So our B percent is what we are going to solve for. So we want to change this formula so we know what we're going to plug that into. So the first thing we want to do is we want to convert that percentage to B over 100 because a percent needs to be converted to a decimal or fraction to do any problems. Now, just using algebra, we're going to get B all by itself. So that means I can multiply both sides by 100 so that the 100s are going to cancel out on this side. And then I'm also going to divide both sides by 150. And that's going to cancel out the 150 on this side so that my B is all by itself, because that's what we want to solve for. So now we have the equation B equals 72 divided by 150 times 100. Now that's what we're going to solve for. So I can multiply that through. 72 times 100 is 7,200 divided by 150. Now you'll notice both of these numbers end in a 0. So anytime you have numbers that both end in a 0, that means I can divide the top and the bottom by 10, which is the same as crossing out a 0 off the top and the bottom. And that's going to give me 720 divided by 15. So now I have a fraction and I need to get my final number. So I'm going to do my long division to figure out what that number is. The bottom number goes on the outside, top number goes in the box. So B, 15 can go into 72 4 times. 4 times 15 is 60, so that's going to give me 12, remainder of 12. And 15 can go into 128 times. So that tells me that 48 equals B. So that means that my B percent is going to be 48%. So now I'm going to look, and my answer C is 48%. Number 17 is also a percentage problem. So this one says 60% of what number is equal to 30. So once again, we're going to put it in our formula of A equals B percent times C, where A is a portion of the total, B is a percent, and C is the total amount. Now I'm going to match them up with my word cues. So I've got 60%. So that's going to be my percentage. Of means multiply. What number is my unknown is equal to 30. So when you have percentage problems, sometimes they give you word cues. So in the example of this one, when we have what or what number, that's going to be your unknown x, or the number you're solving for. Of is going to mean multiply, and is going to mean equal to. So this helps us to set up the problem to make sure that our equations are correct. So now we're solving for C. So we're going to do the same thing that we did before. We want to get C by itself, and we also want to convert our percentage to a fraction. So the first thing I need to do is take that 30 equals 60 divided by 100, and I'm going to go ahead and put my C, because that's what I'm solving for. Now I want to get C all by itself. So I'm going to multiply both sides by 100 so that those 100s will cancel out. Then I'm going to divide both sides by 60 so that those numbers cancel out and my C is all by itself. So that gives me the equation of C equals 30 times 100 divided by 60. So then I'm going to multiply this together. 30 times 100 is going to give me 3,000 divided by 60. Then once again, we see that these both end in a 0, so that tells me I can divide the top and the bottom by 10, which is the same as crossing that 0 out. And that's going to give me 300 divided by 6. So now the last step is to do the long division, where the bottom goes on the outside, top goes on the inside. 6 can go into 30 5 times. 5 times 6 is 30. And then I've got a 0. 6 can go into 0 0 times. So that tells me that my C, or total amount, is 50. And that is my answer D. The last group of problems that we're going to solve are fraction problems. Problem 18 says if 4/3 divided by 1/6 equals P, then the value of P is between which of the following pairs of numbers? So the first thing we want to do is we want to solve the division by fraction problem. So division by fractions, we're going to take the fraction and then we are going to flip the second number and change the sign. So I write down the first number just like regular, change the division sign to multiplication, flip the second one, and then I'm going to follow the rules of multiplication where I multiply the top numbers together, multiply the bottom numbers together. So that's 4 times 6 is 24, 3 times 1 is 3. Now I'm going to do my long division. 24 divided by 3. So 3 can go into 24. That's 8 times. So now I want to know which values. So now I've identified that P equals 8 because that's my answer. So now I'm going to look for where does number 8 fall. So 8 is between 7 and 9. So if you think of this as being on a number line where I have all of my numbers and I found that my answer is right here at 8, but instead of just asking for a single number, they wanted to have groups of numbers. So with this, they gave me between 3 and 4 as one of my options, between 5 and 6 as an option, between 6 and 7 as an option, and between 7 and 9 as an option. So instead of just giving you a single answer, they gave you a range of numbers. So that would have given you the option like if you had a decimal or something in between. So now the number 8 is between 7 and 9, and so that's why our answer is answer D. Our next problem is an adding fractions problem because we want to know what is the value of 4/10 plus 3 over 100. Now, adding fractions is a little bit more complicated than the dividing and multiplying of fractions. The things that we want to remember is that whenever we have adding fractions, we need a common denominator, which we can get by multiplying the two denominators together. Or we need to have a least common denominator. Which is where we're looking for what is the multiple, the smallest multiple that both of them share. So I know we start with the biggest one, and I've got 100 times 1 equals 100. Then I want to look and say, is there a number multiplied by 10 that will also give me 100? And there is. If I multiply 10 by 10, I can also get 100. So that tells me the lowest common denominator of 10 and 100 is going to be 100. So now I'm going to look at my possible answers to help me figure out what my possible solutions might be. So I see that A has a denominator of 100, so that's going to be a possible solution, and C has an answer of 10, and so that's possible that could be a simplified answer. If I look at options B and D, they have a denominator of 110. So if I'm starting with a common denominator of 1,000 or a least common denominator of 100, that's not very likely to end up simplifying to 110. You also want to recognize that one of the common mistakes of adding fractions is just to add straight across. Oops. And if I add straight across, that gives me that 110. So this is wrong. So that tells me these two problems that have a denominator of 110, those are probably trick answers where they're testing to see, do you know how to correctly get a common denominator, or are you going to make the mistake of just adding straight across? So now that I have a common denominator, I've narrowed my options down to 2 options. So I'm going to go ahead and use my least common denominator, but you could do either one. You could use the common denominator or the least common denominator in order to solve your problem. So I've got 4 over 10 plus 3 over 100. So when I'm doing my least common denominator, I'm going to multiply the top and the bottom by the value that they need in order to get that common denominator. So for my 10, I'm going to multiply the top and the bottom by 10. For the 100, I'm going to multiply the top and the bottom by 1. So that's going to give me 4 times 10 is 40, 10 times 10 is 100, plus 3 times 1 is 3, 100 times 1 is 100. Now that I have a common denominator, then I just need to add my numerators, 40 plus 3. So that gives me 43 over 100. And I see that's one of my answers. That's my answer A. Now I want to look and say, can 43 over 100 be reduced to anything smaller? And it doesn't look like they can. So that tells me answer A, 43 over 100 is going to be my final answer. So it's always important that once you have completed your problem, you look to see if it has been simplified. If it has two correct answers, but one is more simplified, the simplified answer is going to be correct. Because we started with the least common denominator, we did our simplification at the beginning, and that's why we had it at the smallest possible value at the end. If we had started at the common denominator, then we would need to simplify. So, and let's go ahead, just because this is a common problem, let's go ahead and do the same problem, but this time using the common denominator, and you can see the difference of this problem. We're going to start out exactly the same. All we're going to do is we're going to have bigger numbers. So that means when you have common denominators, you multiply by the opposite denominator. So you're going to multiply the top and the bottom by the opposite denominators. That's going to give me 400 over 1,000 for my first fraction, 30 over 1,000 for my second fraction. So then when I add those together, that's going to give me 430 over 1,000. Then we're going to apply our simplification, and both of these end in a 0, so that tells me I can divide the top and the bottom by 10, cancel those bottom numbers out, and once again I'm left with 43 over 100. So we got the same answer using the common denominator, and that's as small as it can go. So this is how you would solve your adding or subtracting fractions types problems. Make sure you get your common denominator or your least common denominator, and don't make the mistake of adding straight across. Problem number 19 says, which of the following inequalities is true? So anytime you are comparing fractions, you need to change them so that they are in the same format. So one way to do that is to do long division and turn each of those fractions into a decimal, and then you can compare the decimals to see which one is bigger and which one is smaller. The other way to do that is to do the same patterns that we do when we're adding and subtracting fractions to determine which one is the bigger fraction. So let's go through each of these fractions and walk through them step by step to see how we would do that. So if I start with number A, 3/4 and 5/7. So with this, I am going to write down my first fraction, and then I'm going to take the denominator, the opposite denominator, and multiply the top and the bottom. So that's going to give me 3 times 7 is 21. The bottom is 28. Now I'm going to write down my second fraction, and I'm going to do the same thing, but I'm going to take the opposite denominator, multiply it by the top and the bottom. Now that I have the two denominators are the same, then all I have to do is compare the numerators. 21 is greater than 20, so I see that my inequality is facing the wrong direction. So that means option A is false. So now let's do the next one. The next one says 2/3 is greater than 5/6. So I'm going to do the same thing. I'm going to write down my first fraction, and I'm going to multiply the top and the bottom by the opposite denominator. And then I'm going to do the same thing for the second fraction. I'm going to write that down. And I'm going to multiply it, the top and the bottom, by the opposite denominator. Now that I have the denominators the same, then I compare the numerators. And I see once again that my inequality sign is facing the wrong direction, so that makes B false. So now I'm going to do the next one. The next one is 5 over 8 and 6 over 10. I'm going to write down my first fraction. I'm going to multiply it by the opposite denominator. And then I'm going to write down my second fraction, and I'm going to multiply it by the opposite denominator. Now that I have the common denominators, then I just need to compare my numerators. And I see with problem C that my inequality is facing the same direction as how I solved it, so that tells me that answer C is the correct answer. So when you are doing the inequalities, I like to, as you can see, I like to solve these vertically. When I'm doing the math, that helps to keep things in order, and you're doing the exact same steps that you did when you were adding and subtracting fractions. The only thing that's different is at this very end step, all you're going to do is compare the numerators to determine which direction that inequality sign needs to go, as opposed to adding or subtracting the numerators. Okay, let's look at our last problem. Last problem says Carol works at a bookstore and a restaurant. In a 28-day period, Carol worked 1/4 of the days at the bookstore and did not work 1/14 of the days. On the remaining days, Carol worked at the restaurant. How many days did Carol work at the restaurant during the 28-day period? So let's look at what they've given us to figure out how to set up this problem. So the first thing it tells us is that she's working at a bookstore and a restaurant. It tells us that she's working 28 days. So in a 28-day period, she worked 1/4 of the days at the bookstore. She did not work 1/14 of the days. And on the remaining days, she worked at the restaurant. We want to know how many days did she work at the restaurant during the 28-day period. So let's look at what is that problem telling us. So that tells us we're going to have a total of 28 days. Carol is going to work at the bookstore, at the restaurant, and she's not going to work at all. So that's going to, when I take the days for each of those items, that should add up to 28. Now in the problem, they didn't tell us the number of days. They gave us a portion of the total number of days. So that tells us we're going to need to do some conversions. So let's start with the bookstore. So for the bookstore, it tells us that she worked 1/4 of the days at the bookstore. So that means 1/4 times the total 28 days is going to equal the number of days that she worked at the bookstore. So now if I want to multiply, I need to convert my whole number 28 to a fraction by dividing by 1. Then I'm going to multiply straight across to give me 28 divided by 4. So 28 divided by 4 is going to equal 7. So that means I have 7 days at the bookstore. Now the next thing that it tells us is that she did not work 1/14 days. So we have not working is going to be 1 over 1/14. We're going to take the 1/14, multiply that by the total 28 days. We're going to convert that to a fraction by dividing by 1. Now we multiply straight across following the rules of multiplying fractions. That gives me 28 divided by 14. So 28 divided by 14 equals 2. So that tells me I've got 2 days that she did not work. And then the last thing is I want to know how many days did she work at the restaurant? And we don't know what that is, so I'm going to just call that R, and that tells me this is the number that I'm going to be solving for. So now that I have my numbers, I have 7 for the bookstore, an R for the restaurant, and a 2 for not working. I can go back to this original problem and plug in those numbers. So I'm going to take 28 days, 28 total days, plus my equals 7 days at the bookstore, plus my unknown number of days at the restaurant, plus the 2 days of not working. So now I'm going to add that up. That's going to give me 28 equals 9 plus R. So now I want to solve for R, so I'm going to subtract 9 from both sides. That's going to cancel out to give me 0. So that's going to give me 28 minus 9, which is going to give me 19 equals R. So that tells me I've got 19 days at the restaurant. And that is going to be answer B. So that should be everything you need to know in order to pass your ACCUPLACER Arithmetic exam. Be sure to see the links in the description below for additional supports and resources. I hope you have found this video helpful. Be sure to like and subscribe to get the latest videos by Caz Academy. And be sure to see the links in the description to get additional supports and resources, as well as the official study guides from ACCUPLACER. Best of luck to you on your ACCUPLACER Arithmetic exam, and I'll see you at the next video.